Hello everyone, I'm Alex and today I'm here to explain what is binomial theorem. Binomial theorem actually is highly applies on the polynomial. And what is polynomial? Polynomial actually is constructed from two words, poly and nomial. Poly means by many and nomial means by terms. So polynomial actually is many terms. One of the example is x squared plus x plus 1 is one of the polynomial. And how about binomial? Binomial, the bi means by two, so nomial terms, two terms. For example here, x plus 1 is one of the binomial. Then, binomial terms applies when we want to raise a binomial to a certain power. Here, I try to raise the x plus 1 term to the power of 0. And we know that everything to the power of 0 forms 1. So x plus 1 to the power of 0 is equal to 1. And x plus 1 to the power of 1 is equal to x plus 1 itself, since to the power of 1 change nothing. How about x plus 1 to the power of 2? X plus 1 to the power of 2, if we learned some algebra before, so we can know that it's actually x squared plus 2x plus 1. How about to the power of 3? So it's getting more complicated and longer. X plus 1 to the power of 3 actually is equals to x plus 1 multiplied by x plus 1 squared. And we just copy down the terms from the, just now we calculated, x squared plus 2x plus 1. It's just the same term as here and copy it down. So we can use the x terms to multiply the whole line at the 1 term multiply the whole lines. It's getting a bit longer, so I just write the right hand side. So here the orange term is x cubed plus 2x squared plus x. And the blue terms is x squared plus 2x plus 1. Here as a reminder, I move it backward a bit to make it terms align. It's easier for us to add together. So the final answer is 1 plus 3x plus 3x squared plus x cubed. And this is the answer for the x plus 1 to the power of 3. Then how about x plus 1 to the power of 4? The step of doing x plus 1 to the power of 4 is almost same as the doing the x plus 1 to the power of 3, but just getting longer. So here we take the terms x plus 1 multiplied by x plus 1 to the power of 3 and so on. Actually, here has an interesting fact that makes the binomial theorem work. We know that for the blue terms, it's actually the terms for x plus 1 to the power of 3. And here is the x plus 1 to the power of 4. We can find out that the 4 here actually is the sum of the first coefficient and the second coefficient. And the 6 here is sum of the second coefficient and the third coefficient. Same as the 4. And the first and the last is always 1. If you move the shape a bit, you can find out this shape. 1, 3, 3, 1 and 1, 4, 6, 4, 1. And here it starts with the x squared, x cubed, and x to the power of 4. This shows us that when we add like this, give us a next term. If we continue doing this, so we can get the next term. So here now we already got x plus 1 to the power of 5. By continue doing this, we can get x plus 1 to the power of 6 and so on. This pattern, after taking off those x terms, it will form a triangle called a Pascal Triangle. For the row of the Pascal Triangle, we name it according to its power. The first line is with the 0 power, so we call it as 0 row, then the first row, and the second row, and so on. Then the terms also, you start from 0, here is the 0 terms, first terms, second term, and so on. If you find a certain coordinate in the Pascal Triangle, n row and r column, we can just using this formula, n factorial over r factorial, n minus r factorial. For example, we want to find the fifth row, third column. So fifth row, third column here is 1, 2, 3, 4, 5. 1, 2, 3. So the answer is 10. We can just use the formula. We use the calculator, calculate 5 factorial over 3 factorial and 5 minus 2, 5 minus 3 factorial. Then you can get the answer is equals to 10. After we know how to use the Pascal triangle, so we can find out the x plus 1 to the power of 6 easily. So we just find out which line is for the power of 6. So this is the first line, the power of 1, power of 2, power of 3, 4, 5, 6. So this line is the power of 6. Then I just copy its coefficient. This is x to the power of 6 terms. This is x to the power of 5, x to the power of 4. And add them together. This is the expression of x plus 1 to the power of 6. Actually, there's something hidden here. Don't forget that we raise the x to the power of 6, we also raise the 1 to the power of 6. So actually here has a 1 to the power of 6 at the last term, 1 to the power of 5 at the second last, and so on, 1 to the power of 3, 1 to the power of 2, 1 to the power of 1, and 1 to the power of 0. Since 1 to the power of anything is still 1, so here it actually doesn't make any effect. But for the next question, it does make some effect. So for the power of 4, let's copy down this coefficient. So it's 1, 4, 6, 4, 1. Something to be mentioned, actually between the summation of two powers is always equal to the total power. For example, the 3 plus 3 is always equal to 6, and the 4 plus 2 is always equal to 6 for the whole expression. Either one with terms of 4, then another one should be 0. So the first term, I choose to let the 2x to the power of 4, so 3 is to the power of 0. And the next term, 2x to the power of 3, 3 to the power of 1. 2x to the power of 2, 3 to the power of 2. So we can express it slowly and get its coefficient. So the 3 to the power of 0 is 1 and doesn't make any effect. So 2 to the power of 4 is 16. X to the power of 4 plus 96 x cubed plus 216 x squared, and so on. And this is the answer, the expression for 2x plus 3 to the power of 4. So binomial theorem can be expressed in a plus b to the power of n, and the coordinate of the Pascal triangle with the first power a to the power of n and b equals b to the power of 0, and the second coordinate of the n row, the a power getting lower and the b power getting higher, and so on. And finally, the last term, a to the power of 0 and b to the power of n with the last coordinate in the n row. And the coordinate can be calculated using this formula. Remember, the n here representing the row and the r here representing the column. And always remember, when we're counting the Pascal triangle, we count from 0 row, first row, second row, third row, and 0 column, first column, second column, and third column. And that's all for today. Thank you very much, and please accept the like button.